topic is XSS. Cross-site scripting. Okay. Now, cross-site scripting is what? It's an attack. Okay. Where attacker will exploit the vulnerability dynamically over a web page. Okay. And when does this attack appears? When unvalidated input data is been included over a browser. Okay, so attacker, what he is going to do, he is going to inject a malicious JavaScript or ActiveX or HTML or Flash, okay, such kind of a thing in order to get an pop-up. In order to get an pop-up, that means he will hide his ad in the frame. Okay, a malicious script code will be written and taken the advantage. Okay, so generally you can say in cross-site scripting how it has been working. So first we are going to inject, okay, so, okay, where we are going to inject a query over a field. So field can be your URL, field can be your search box, or field can be your username and password. This fields, blanks field. Okay, so the code typically written into a JavaScript language. Then a payload is being used. Attacker, what he will be doing, he will be crafting a payload which includes your malicious code they want to execute. Okay, then once the payload has been created, then attacker will deliver that payload to the targeted machine. Okay, by tricking or by clicking to the malicious link, by tricking that user, or by giving the link. Okay, once that has been delivered, the next part comes over here is your execution. When the targeted system click on that link, or once he is having that web page and he provide his code, and once the code has been written and been pasted over the field, it will get executed. Okay, and executed where? Into the browser. Now there are different types of an scripting attack as well. So we have stored XSS, we have reflected XSS, we have DOM-based XSS. Stored XSS is what? Uh, Permanently we will be storing our script into the targeted server. So whenever we want that server to be accessed, we can take an help of that already previous stored XSS and get inside the server to get more information. Then we have reflected XSS, very commonly used. Okay, so just a malicious code has been written into the URL, and it will get displayed over the browser. Okay, then we have DOM-based access as well. This type of an XSS, you can say this vulnerability exists when there is a DOM-based model is being used into the web page, DOM environment. Okay, now how we can perform this attack, or when we are doing a testing, how we can use, how we can uh, do this attack as well during that time. Okay, now first thing, what do we have is your condition again. We need to identify whether we can perform this attack or not. How we are going to identify? By looking at the condition. The condition, what my for XSS, what my conditions have been saying. First, the condition is find the input field. Okay, find the input field. What will be your input field? It can be your URL, it can be your search box, or it can be user ID and password field. Okay, and what are the input field? Where you are going to provide, where you are going to write your script. That will be your input field. Okay. Once you identified the input field, my second condition has been saying whatever you are providing as an input should get reflected as it is. Okay. Whatever you are providing into an input field should get reflected as it is. Okay. So let's give it a try. This is my website. Okay. Now, what is my first condition? Then if not, then we will moving into the another page. That is your online banking, or we will look into different other pages as well where we can get the input field, where we can get the empty box. Okay. So first is to find the input field, and the second condition is whatever you provide as an input should get reflected as it is. So whatever I'm giving over there, whatever I'm writing into the input field, exactly the same thing should get reflected onto the screen. Okay. So let's say I'm saying this is an input field. I'm writing my name after this. So it should get reflected, but it's not. Redirected to another page. Okay. So that means this is not my input field. Let's give it a try over here. Is it getting reflected? Okay. Now, we haven't performed an attack yet. This is just to verify whether we can perform or whether we can do a cross-site scripting into this web page or not. Okay. If it is getting reflected, that means we can initiate our attack. This website, this field is vulnerable. We can take an advantage of it. Okay. Now what we are going to do, we are going to perform one attack which is known as your reflected XSS. Okay. So a malicious script will be written, and that script will be embedded into the URL or into the search box. Okay. Same as it is. Okay. Whatever we are providing as an input, it will get reflected if it is vulnerable to that XSS attack. Okay. Now, how will be our script? It will be something like this. Say opening script. What I want to get displayed, alert message. In that alert, what will be the message? Let's say 123. This is my message I want to get displayed, and closing the script. It's an JavaScript. Okay. So this will be my script. Let's use this. Okay. For space, %2, %20, for exclamation, %21. This encodes have been used by the developer to give a space. So I cannot give a space directly. So we are using this encoder. To go to the next line, we are using this encoders. Okay. So what I have written, I have used a script, opened a script, alert I want to display, what is the message, 123, and closing the script. And it is getting reflected as it is. Now let's do one thing. Let's perform, or let's try to see what are the different types of an XSS attack. Okay. So let's start with level 1. Now over here, what will be my input field? Whatever you provide into an input field should get reflected. So what I'm doing, I can see level 1, hello ZXM, name equals to ZXM is been written. So let me see, it is getting reflected. Now let's try our script. Okay. Now let's look into level number 2. Okay. So this I am not doing. This has been done at the back end. So this time the developer who has created the website, he is very much smart. He is blocking the script tag. Someone is trying to perform this attack. Someone is trying to use the script. Let's block it. Okay. So what we can do, we can play around with the script tag. Okay. If my script tag, this is getting blocked. So what I can do, I can go with other possibilities like everything in uppercase or something like this. SC in uppercase and rest all in lowercase, or S in uppercase, T in lowercase. All the possibilities, we can give it a try. Somewhere some tag won't be blocked. Okay. So let me go with script SC in capital. Okay. So like this, we can play it around. Okay. Let's try to see other format as well. Okay. So now I'm going with level 3. First, to identify whether we can perform the attack or not. Yes, we can do. Now what I will be doing, I will be simply using the script, opening the script, alert that need to be displayed is 123, and closing the script. Now again the same thing, but what was the difference in level 2 and level 3? So this time it is saying alert 123. Okay, the whole script tag is been blocked, including your greater than and less than sign. Okay, so what I can do, I can try all the possibilities, the script tags in different ways. So I can write it SCRIPT. Nothing happened. Now let me go with all the uppercase. No result. Nothing is working. The script is not working over here at this place. Whatever I am writing, it's not able to execute. It's not able to read it. Okay. Now, at this moment, what I will be doing, I will be checking for the page source as well, on which line my script has been running. Okay. So simply what we can do, right click on the page, view page source. This is the code. Now we can see over here in which line our script tag or our script is been running. Now over here, the tag is getting blocked. So now at this point of time, what we can do, we can move our script tag into next line. If it is getting blocked on line number 40, then why don't we give it a try onto line number 41? Okay. Now to move this from line number 40 to 41, what we can use? Just now I had shown you something. What was that? Percentage URL encoding. Okay. That is known as your URL encoding. Percentage 20 is foreign space. Now I want to move the whole tag into next line. For that URL encoding will be different. So it will be percentage 0A to move in next line, followed by the whole tag. Let me copy this. Going back to the page. Percentage 0A script followed by the alert and closing the script. Am I getting a pop-up now? If I check for the page source, is my script tag has been moved into next line? Okay. So whatever we are providing as an input is getting reflected as it is. What the conditions have been meeting. Okay. Now over here, what do we have? We have an image. Okay. So as an attacker, what we are going to do, we are going to take an help of this image. Okay. So first, the loophole, I've tried to identify whether we can perform the attack over here or not. Okay. So the name of the image is img equals to std.png. Okay. Let me try to change the name. Okay. One more thing. How we are going to take an advantage. So what a pen tester or attacker will be doing, first he is going to create an error in this image. Once the error is been created, once the image is been broken, then we are going to take an advantage of that broken image. Okay, we are going to run our code inside that broken image to in order to get the pop-up. Okay, so first take an advantage of that image, broke that image. Okay, create an error onto that image, and then give your particular syntax inside this image in order to get an pop-up. Okay, so let's try to break the image first. So what I will be doing, I will be changing the name. We'll try to change the name. I can write anything, literally anything over here. Okay, so since I try to change the rename this image file, it has given me an error. Okay, so condition number one, we had created an error. Now we are going to take an advantage of this error. Okay, now how we are going to take an advantage? By writing a script. So the script will be something like this. The name of the image which we had given as of now, that is anything. Okay, so run a command inside this anything. Okay, what to be displayed? Error. Where? On error. What will be your alert? 123. Okay, so inside this image file, inside the error of this image, create an error alert, that is 123. It gave me an pop-up alert box. Okay, okay, now what I'm doing, level 1, level 2, level 3, level 4, what are this? I'm performing the same attack into different ways. If something is getting blocked, so what are the other chances to perform the attack? So it's not a one single way to perform any attack. Okay, so we are identifying the things by looking at them. Okay, so at the same time we are also increasing our level as well. So as I said, increasing our level, let me try on to the level number 6 now. URL is getting reflected. Let me run our script tag. Okay, let's try to look into the page source as well. On line number 40, XSS detected. Okay, what I have given as an input, script alert 123 script. Have a look onto the URL. Is it the same? Okay, now what are Unicode? Let's say this is our Google page and I check for the page source. Okay, now at the back end of this code, you will see somewhere under the top by the name of an UTF kit. Here you go, UTF. which means it's a way of an encoding. The URL only understand this encoding method. Okay, it's the way of an encoding. So when I'm saying a way of an encoding, if you are using any Unicode, so you have to go with the encode of that Unicode as well. Okay. Similarly, we have a rapid table for it. So we can simply write Unicode rapid table. Here it is. Okay. So for each and every character, we have an escape value. So if I go with exclamatory, the escape value is percentage U0021. So in place of exclamatory, we can use this escape value. For one, the escape value is /U0031. So my script is less than greater than alert 123 less than greater than script. So for this, what is the escape sequence? Less than sign /U0003C followed by script tag, and let's close this /U0003E followed by alert 123 and close it. Okay. So what we are doing, we are using the encode for greater than and less than sign. And from where we got this encode? From an Unicode character table, rapid table. Okay. First I'm executing it over here. Let's see it is able to read it or not. Okay. Same thing is getting reflected. Let's give it a try over here. Okay. And whatever I'm giving as an input is getting reflected as it is. Isn't it? URL is also not getting changed. And the same thing is been executed as well. Okay. Now. Okay. So yes, we need to review it as well. Even many websites who are having HTTPS, they are also vulnerable to this particular attack. Many websites. Okay. Now this time something different, isn't it? What am I writing is getting reflected, but not getting executed. Okay. The whole tag is getting reflected. He is able to read it, but he is not able to execute that tag, execute that command. Okay. Let's try to look into the page source. Identify what is happening. Just take a minute of an time. Okay. One more thing, try to identify what is being written over here, what is getting executed, and what we have written. Okay. We have gone through script alert followed by the closing the tag. When we check for the page source, it's in percentage 3C, and what is getting reflected is per and LT. Everything is different over here. Okay. My greater than less than are getting blocked. In place of that less than and greater than, percentage 3C is used, and again that percentage 3C is getting blocked. He is able to only read and LT. Okay. Now what are this and LT? This again is your Unicode. Okay. So what we are going to do, we are going to decode this Unicode. We are going to go with an decoder, URL decoder. If my less than or greater than are getting blocked, okay, let's decode this. Use another way, use another thing. For less than, the URL encoders are percentage 3C. Percentage 3C is also getting blocked. Further to that, can we encode it? Percentage 253C. Okay, so we can go with percentage 253C. If percentage 253C is again getting blocked, let's go ahead and encode it further. Percentage 25253C. Okay, we are simply encoding it. For less than sign, encoder is percentage 3C. Further to that, encoder is percentage 253C. So let's give it a try. Script. Okay, then we'll be closing it. Encoder is percentage 3E. Further to that, encoder is percentage 253E. Alert 123. And closing the script. Okay, so first let's try to run it in our page source. Okay, able to read the script tag, script alert 123, and closing the script. Okay, let's try it over here, getting executed or not. The script tag is getting executed now. He's able to read now. Okay, so what we have done, we have decoded that. We have used a decoder for it, encoder for it. Okay, now these are what, again, by analyzing it, we can move over step, we can move to different steps. So we are not having one particular step to perform any kind of an attack. There are different ways to identify it. Okay, so we are going to look into each and every scenario down the line when the pen testing has been done. Let's say you are doing a pen test of a website. Okay, so similarly you are going to test that website. to identify whether that website is vulnerable to cross-site scripting or not. So what are the possibilities available? We have a number of possibilities. First, try to go with that particular pop-up. First, try to go with the simple script. Not getting executed, let me try with another way. Not getting executed, let me try with another way. Okay, try all the case scenario, try every possibilities. If still not getting reflected, that means it's fine, that website is having a little bit of insecurity. You are not able to breach that security, but as a pen tester, you need to go with each and every possible scenario. Okay, and when you are going to try these possible scenarios, if the conditions have been meeting, now I'm going to show you uh, how we can perform an attack over to an server. Okay, so this time we will be using all the things whatever we have learned so far. Okay, so all the possible scenarios we are going to try it over there. There's a machine by the name of an bat, so we are going to attack into that machine. Okay, sudo su claiming for the root access. Privilege escalation has been done. Okay, now I need to identify what is the IP address of that machine. So what we are going to do, I have configured the IP address of my Kali machine is 192.168.10.129. Okay, so we'll be running an app scan now. App scan 192.168.10.0/24. The IP address is 137. Okay, so let me quickly run an nmap. How many ports are open? 3 ports. Port number 80, port number 443-3306. Port number 80 stands for STDP, 443 stands for STDPS, and 3306 is for. Now, whenever you see port number 80 and port number 443 are open, straight away open that IP address into the URL, into your URL. Okay, straight away copy that IP address and paste inside your browser. This is how your bad store will look like. Okay, now what do we have in this website? I can see there is a search box over here, a home tab, what's new, sign our guest book, view previous orders, about us, my account, login and registers. Okay, so I'm getting lots of things over here. Sign our guest book. Perfect, I'm getting 3 fields. 3 fields. Can I try an XSS attack in these 3 fields to identify which particular field is vulnerable? Can we do that? Script alert. So if first field is vulnerable, give me a pop-up of 1. If second field is vulnerable, give me a pop-up of 2. If third field is vulnerable, give me a pop-up of 3. This is what I want. That's it. Okay. I'm getting a place where I can write a command, where I can use this XSS attack. That is your fields, your name, email, and comments. Now, what we are doing, we are simply writing our script. If first field is vulnerable, alert will be 1. Second field is vulnerable, alert will be 2. If third field is vulnerable, alert will be 3. If no field is vulnerable, you won't be getting any alert. Okay, you won't be getting any pop-up. So let me try to add it. I'm getting a pop-up. First field is vulnerable. Great. I'm getting 2 as a pop-up. That means my second field is also vulnerable. My third field is also vulnerable. One more thing has been happening. My script is also getting stored over here. Can you see Friday, June 23rd, followed by date and time, followed by the script which we have used. That is also been stored. Where it has been stored? Into his database. I can see the previous records as well. My script is getting stored. Okay. If I try to add an entry, Abhishek, email ID, visit Gmail, comment, hello. Okay. This is additional thing I'm adding into the database. When I'm storing this information into the database, what is happening at the back end? My script is getting executed before the data is getting stored, isn't it? This is known as your stored XSS. So you can store the script into the database. Whenever anyone, any particular person try to store his information or try to access the database, first thing what is going to happen, the script, the particular XSS command is going to execute because we had already stored that information into the database. Okay. Now with this MX toolbox, we are getting an information of this domain that is of an ICICI bank that only this IPs has been allowed internally. Okay. If they want to communicate with each other, they should be sitting into this domain, into this range. Okay. Now, as an attacker, what attacker will be doing, he will try to find out a loophole in between this. Okay. Loophole as in try to get inside the server, or if application is being used from a client's end, If that application is vulnerable, then why can't he take an advantage and make the transaction? We are not attacking the website or the web server. We are attacking the application which has been used inside the phone, or that phone. Okay, that mobile phone which has been used, operating system is outdated and already the vulnerability has been listed. Easily anyone can get inside that mobile device and see what he has been using. So it's not like that only the website should be vulnerable. Any point of thing can be vulnerable. Any point of an environment can be vulnerable. It can be your device, it can be your network, it can be your application, or it can be the website. This is the vulnerability to your IoT devices. And it's live and active. This IP address is live and active and still vulnerable. If I click into any of the this IP address, it will give me the information of it. What are the ports are open? Where this device has been located? Complete detail of it. Okay. Now, if I'm using a smartwatch, whatever data is getting collected, let's say I'm walking, the steps are getting counted. Okay. We are doing a performing exercise. The details have been calculated. Now those details has been transferred to your mobile phone, isn't it? How it is getting transferred? With the help of a Bluetooth. Now to access that data, what has been required? To access the data of the smartwatch, what has been required? Pair them first. Once it has been paired, application has been installed. Yeah. And from where we download this application, okay. Along with that, the data which has been stored in that device. Further to that, the data will be stored into your cloud as well. Now, for an attacker, this will be your playground. Just understand. It can be an IoT device, it can be a mobile phone, it can be a cloud environment, it can be an application, or it can be a web browser. If any of the field is vulnerable, we can see what will be the damages. While transferring the data over in Bluetooth, a bluejacking attack has been done. Straight away, I can get inside this device or in this device as well. If your router is vulnerable, okay, always change the default ID and password. Okay. If I am been traveling or I am been walking by your near to your street or near to your house, so first as an attacker, what I will be doing, I will try to search what all network ranges are there, what are available networks are there in this particular area. Okay. Then I will try to identify what router they have been using. If they are using XYZ router, let me go with a default ID and password to get inside it. If I'm inside that router, easily I can see what all devices have been connected, what are network, in which network channel you have been setting, what data has been traveled. Okay. So always try to reset the default ID and password. Okay. So when you are installing the routers at your place, so are you connected with a network? I can simply go with a login ID and password and I can see what network they have been using inside it, isn't it? You are simply connecting a wire at the first time. You are not connected to an internet. To connect to an internet, inside that setting, we are providing an ID and password which has been given by the ISP. Once that ID and password has been matched, then you are connected to a network. To access that router, no network has been required. So that can be also a point of an attack. Your device, the application which has been used, if that application is outdated, that can be an also a point of an attack. Your operating system is an outdated, that also can be an point of an attack. Okay, from where the application has been downloaded. If it is downloaded from a third party, again a malicious code will be sent. The details have been stored onto the cloud. If the cloud field is vulnerable, easily we can get inside this device as well from by taking the advantage of it. Okay, so this can be the field. This is a design, a workflow. A network has been designed in order to set up the particular all the activity into that environment. Okay, and in addition to that, what we are doing, we are writing a rules, we are creating a rules, we are adding a control in each and every devices. Okay, how it is been identified? With the help of an ISMS, information security management system. We are implementing certain rules. Okay, before to that, we are testing it, what rules or what particular controls need to be added. For that, we do a risk assessment by finding out what will be the possible risk are there. Add and control. Is there any possibilities? Add and control to that so that we can mitigate that risk. We are simply narrowing down our events. We are not saying we are 100% sure. We are simply narrowing down all the event. Now this is my internal network. Let's assume. Now how the network, how this particular firewall architecture will be identified. How we are going to install a firewall into the network. Okay. So first will be my internal network. Then let's say I want to connect to an internet. Now in between, how we are going to place the firewall? We cannot place the firewall directly. It should be placed, or it should be placed into an particular articulate manner. Or let's say I want to add, along with firewall, I want to add the IDS and IPS as well. Okay. Now whatever request has been made from my internal network, first it will go inside the firewall, then the request will be forwarded to the internet. Let's say I'm adding an IPS as well. So I will be adding that IPS behind the firewall, not before the firewall. Okay. Whatever request has been coming, first it has been identified by the firewall whether that request to be allowed or not. If it has been allowed, whether that request is malicious or not, it has been checked over here. If it is not, forward it to the internal network. If we are placing a IPS at the beginning, how we are going to identify whether the request is an whether we can accept this request or not? First, that need to be identified. We can access facebook.com or not. If we can access inside the internal net, inside the organization, forward the request. Whether that facebook.com page is a legitimate one or not, it's a fake page or it's an legitimate page. Identify it from here. Yes. It is a type of your IDS and IPS. Okay. That need to be placed behind that particular firewall. It's a network intrusion. For that, which we have HIDS as well, hardware based. HIDS and HIPS. We have NIDS and NIPS. Okay. It is an IPS. If you are using any particular IPS, so it will be. And if you are using, let's say, uh, uh, we have different set of an protocol has been used into the network. So according to that, organization can adapt whether we want to detect or whether we want to prevent. So again, a control has been added. How that control has been added? By performing a risk assessment. We required an IDS, we required an IPS. We don't want to detect, we want to prevent that attack as well. Two controls have been added: detection and prevention control. DMZ. So what we are doing, what we are placing inside a DMZ, the servers, the secured one. let's say I'm using, I'm having an email server. Okay. So for an organization, email servers have been placed inside your DMC. So whatever request has been made, it won't be going into an internet. First, it will be going checking inside the DMC whether our server has been hosted over here or not. If yes, give the reply back. Connect with it. So we are hosting certain servers inside the DMC. Everything will be inside our network. And internet is outside our network. We are preventing our internal network. So DMZ, IPS, IDS, everything will be in our premises. So when I said when we design this architecture, so first what we are placing? We are placing the firewall. After that, everything has been placed. From our router, request has been made. Then the request has been forwarded to the internet. So we have a firewall. Then we have all the devices connected. So in each and every device, we will be adding up and control. If you are using a router inside that, what do we have? If you want to check what are the wireless components we have been using, just take your router and check at the back side of it. Authentication has been used. So over there, we are using certain algorithm and authentication. WPA, WAP, WPA2, WPA3. We started with an encryption, WEP encryption algorithm. Again, it was a weak algorithm. We upgraded to WPA. We are using WPA2. AES and CCMP algorithms have been used in that. Okay. And as of now, we are in transaction to WPA3, the third generation. Wireless security has been used. Okay. So over the period of some time, this will be adapted by each and everyone, by your routers as well, internal network as well, and by the organization as well. WPA3, the third generation encryption. Again, what is this? This is again an extra layer of security. Now, again, inside this, we are adding some more additional control. Okay. So we are configuring your host file as well inside the device, whether that request to be made or not from our device. So in organization, let's say Facebook is not been allowed. So we will be changing the host file. Okay. If someone is making a request for www.facebook.com, redirect its request to a loopback IP or redirect its request to an unresolved IP. Okay. Again, who is configuring this host file? Only the admin member. As a normal user, I cannot open or I cannot edit that host file. Okay. Similarly, for organization, nowadays we are using the VPN service as well inside the network and access the network because it's a secured one. No one will be available. No one can access this from an internet. As a normal user, so from my laptop, I cannot access the internal network of an organization. For that, a tunnel has been required. That is your VPN, a secured channel.
Mhm.
IP will be listed into that channel. If a request has been coming from this IP address, that means it's an internal IP. We have an authentication servers in between who is doing this verification for us. What I will be doing now, I will try to capture the request. Okay. Now how that request will be captured with the help of an burp suit. So we have a tool by the name of an burp suit. Okay. So burp suit is what? It's you can say it's a proxy tool, proxy between your system and the server. So basically, whatever request has been made from your server's end, okay, or whatever request has been made to your servers, easily we can capture all this request from our device to the server, from our device which has been sent to the servers. We can analyze that request as well. We can forward the request as well. Okay. So let's give it a try. Okay. Now, before to that, let me show you one more thing, one more interesting thing. What's new? If I click onto the what's new, what I'm getting? a list of an items. Let's say I want to purchase this thing. Let's say I want to purchase this magic rabbit. Add item to the cart. Now, what I want everyone to notice one thing. Notice this URL. What changes are happening in this URL? Okay. What's new? This is my URL. Adding something into the cart. Action is getting changed. Okay. Now action is what? Cart add. Now let's view what is there inside my cart. What is action now? Cart view. Let's place an order. Let me place an order of that. The thing. Okay. Okay. Thank you for using Visa. If I click on OK, your order has been placed. Action equals to order. Okay. Now, let me add each and every item into the cart this time. Now, if I want to see what is there inside my cart, what was the action? Okay. The action was cart view.
No space.
Okay. Now, what was the action once the payment has been done?
Yes, order.
Did I make the payment? This is known as your IDOR. Insecure direct object reference. Okay. So this vulnerability is known as an IDOR. and there are many websites are vulnerable to this. This is how we can take an advantage of that URL if it is vulnerable. Okay, if you see the action are keeping on changing, let's give it a try. Let us try as well. Can we change it manually into the URL or not? If we can do that, that means it's easily it is this particular URL, this particular website is vulnerable to an IDOR. Okay, if it is not secure, then only this vulnerability is existing. Okay, now if I can change the action from one place to another place, so can I go inside the admin portal as well by changing the action? Secret admin menu. So let's see what I can do with this menu. I want to delete a user. Okay, what we are getting? Something weird happened. You try to access admin portal, you are not an admin user. You must log in as an admin user first. If you are trying to hack, I know who you are, followed by my IP address. Okay, so developer is smart again over here. Is playing with us. If I'm trying to get inside the admin portal, I'm not. I'm not able to. So at this point of time, what we can do, we can use the burp suite. Now to use that application, we can simply write burp suite, hit enter, the tool will get open for us. Okay. Again, this burp suite is very powerful tool. We can use this tool to perform the attack to find out the vulnerability as well. Now for that, we will be required an paid version of the burp to do scanning and to identify, to do a vulnerability analysis as well. Okay, I accept. Don't want to update. Okay, so temporary project, next, start burp. Okay, now inside this burp, we have many options available. We have a dashboard. So whatever request you are collecting, you can see it from the dashboard. Then we have the target as well. So you can set the target. You can check for the proxy as well if the interception is on. So all the requests will be collected over here. We have an intruder. We can set up the host. We have a repeater. So you can use a repeater as well, the sequencer, the decoder. Again, we can use decode some hashes from here as well. Okay, we can decode it, we can encode it. We have a list of certain hashes inside this. We have comparer, logger, extender. Okay, project option we can change from here, normal to an open-ended project, and we have a user option as well. If you want to change with any setting for the user, you can change it from here. Okay, now as of now, I will be using this as a proxy tool. So where I will be using this proxy into our web page. This is our web page. I will be using it over here. Now before to that, I'm going to change certain settings of my web page. Settings, privacy and security. Okay. network settings. Okay, so I'm going to configure my network setting to a manual configuration. Manual configuration, what I will be using over here, I will be using a loopback IP. Okay, now what is a loopback IP? And the port number will be 8080. Use this for HTTPS as well. Whatever request has been made, whatever request has been forwarded, that request will be forwarded into this loopback IP, so I can capture it. Okay, let's go back over here. Let me create a new account. Okay, so the details will be captured inside and burp. So for before to that, let me turn on the interception, a full name, account of an Abhishek @gmail, password is favorite color hint, let's say blue. Let me click on register. Straight away request has been captured inside my burp. Can you see? I clicked on register, the request has been captured, but at the back end it's still loading. The request is not forwarded to the server as of now. I am having the request. Okay, I can see what information that user has given. The full name was Abhishek, email ID. If I check it, scroll it over here, this is the email ID. If I check for the password, this is the password. Hint blue. What is the role of that user? Role equals to U. That means U stands for user. Whenever new account has been created, you will be always getting a normal user privileges. Okay, so as of now I will be changing the privileges of that user from a normal user to an admin user. Let's change the role from a normal to an admin. Okay, giving the role as an admin, I have the ID and password as well. So whenever I want, I can have an access to this account and I can play it around. Okay, now let's store this thing. Let's forward this request to the database. Forward, this is the request. Forward, done. Can you see? It's been stored. Welcome. Welcome Abhishek. Now let's reverse it to the manual. Okay. Now account has been created by the name of an Abhishek. Now this account is having which role? Admin user. Now can I access the admin portal from this ID? I can. Now I can delete the user. Let's say I want to delete this user. Delete. Done. Understood how we use this tool in a attacking perspective? How we took the advantage of the burp suit?